Okay. The next question is simply identical trees again. Same tree. Okay. So sketch. Um, so basically, question क्या है? The question is simply whether the two trees are identical or not. So we have same tree case where the trees are indeed identical. So we have one, two, three case, and we have one, one, two, one, two, one case, right? This is two, this is one. So how do we solve this? Simply, there are three criteria which we need to fulfill, and also the tree has to exist. The root has to exist. If one of the roots do not exist, then you simply check whether both of them are null or not. So the first thing that you check is whether the current root root is equal or not. And by root I mean not just the node, but like the value, the face value of that node is equal or not. Second criteria is basically whether the left subtrees are equal or not. This is left subtree, and this is the root. And the third thing is whether the right subtrees are equal or not. Right. So if I go back, so for this case where we do have identical trees, I can see this case is what we call identical trees or a case, and this is the not identical unidentical trees case. So the first criteria for this tree, which is P, and this is Q, this is P, this is Q. So the first criteria is simply whether the current node is equal to the current node of the right tree, right? Now, the one is equal to one, so the first criteria is met. The second criteria is whether the left subtrees are equal or not. Left subtrees are equal or not. Third criteria is whether the right subtrees are equal or not. So the left subtrees given to us are 2 and 2, and the right subtrees are given to us are 3 and 3. Now we do the same thing. We check whether the first criteria is met or not, which is basically roots are equal or not. The root value is 2 and the root value is 2. So this is met. The second thing is whether the lefts are equal or not. So left is null, right is null. So both of them are not defined. So we had this base criteria where if either one of them are is not defined, then you simply check whether they both are null or not. So how do you check that? You basically check whether P is equal to Q or not, and in this case both are null. So suppose we had 4 here, it will give me false. So which basically means that this tree has more to it. This tree is still going on, but this tree has ended, and hence they are not identical. So false signal from here, but in this case we have null over here and null over here, and the left subtrees give us a good to go that this is identical, and the right subtrees also are null and null. So they also give us the same thing that both are equal. So this is good to go, and the first criteria was already met. So this gives me that the left subtrees are identical. Now in this case, the value of the root is equal. The first criteria is met. The second criteria is the left subtree should be equal. So left is null and null, and that is also same. You make equal equal because both are not defined and they are null. So there is no extension to either of the trees, and this is met. And the third criteria is simply this: whether the right subtrees are equal or not. So both of them are null. So this is also met. So this signals a true, and this signals a true. And since the root was already equal, and this is already met, so the left gives us true, the right gives us true, and hence the trees are identical simply. Um, in this case, we have the first criteria met. One is equal to one. Second criteria is whether the left subtree is equal to the right subtree. Sorry, left subtree of the left tree is equal to the left subtree of the right tree. So in this case, we had one and two. So we have two cases where we have one and two. Second case is the right subtrees, which is like two and one. So in this case, the first criteria does not meet. Now the next steps or next comparisons are obsolete because this gives us false, and whatever results are there, whatever the combination permutations for the second and third is there, this will always return me a false. So, but in this case, this is null and this is also null. So this will return me a true because p equal to q is uh, true here. Both have null and there is no extension to either of them. So the left one gives me a good to go, and the right one gives me a good to go because they both are also null. So first one is false and the other ones are true. So this will give me a false. So the left subtrees are not identical, and the right subtrees, the face values, the roots are not equal. One is not equal to two. One is equal not two is not equal to one. So the first one is false, and then the left subtrees are just null, and when we compare them, we just get a true. There is no extension, and the same case with the right ones. They are both null. They do not exist. They are not defined. So we just do p equal to q, and that is also false. So this sorry true, and this gives me true. So this signals a false as well. Now the first one is true, second one is false and false. So even if this is true, but others are false, and this will signal me a false, and these trees are not identical, right? So if I try to code this, this is a very simple code where for normal cases, what do? You simply match the current roots value is equal to q key value, and you check whether the left subtrees are equal or not. So is same tree p ka left and q ka left. Okay. And the second thing that you check is whether the right subtrees are equal or not. How do you check that? Same function recursively called p का right भेज दो and q का right भेज दो. Okay, and the base criteria where both of them or either one of them is null. So if both of them are null, that means they both have ended, and if not, there is some extension to it. So if p does not exist or undefined is undefined and q is undefined, you just check whether both of them are null or not. Okay, so this works well. Now, the space complexity and time complexity. The space complexity we'll discuss later. The time complexity is simply of number of nodes because you're traversing all the nodes essentially. Um, in this case, the space complexity is of h because the space taken, the maximum space taken, will be the height of the tree, and in the imbalanced trees or unbalanced trees, the deepest height will be space complexity of h. And in the case of a skewed matrix, where the nodes are like stacked in like one direction, the space complexity is of n, which is simply because you're traversing all the nodes in this case, so of n.